Hey there, science fans, and welcome to Science in 10 Minutes. Today, we're diving into the fascinating world of vaccines. These tiny doses of scientific brilliance have revolutionized public health and saved countless lives. Vaccines are like secret weapons in the fight against infectious diseases. They work by giving our bodies a sneak peek at a germ, like a virus or bacteria, without actually making us sick. This preview allows our immune system, our body's natural defense force, to prepare for a real attack. Think of it like this. Imagine showing your dog a picture of a scary vacuum cleaner before turning it on. The dog might be a little scared at first, but it won't be nearly as terrified as if it encountered the loud moving machine for the first time. In a similar way, vaccines introduce a weakened or inactive version of a germ to our immune system. This training session allows our bodies to build up defenses, called antibodies, that are specifically designed to fight off that particular germ. Before we delve deeper into the magic of vaccines, let's take a moment to understand our adversaries, germs. These microscopic organisms, including viruses and bacteria, are everywhere. While many are harmless, some can cause diseases. Germs spread in various ways, through the air, water, food, or even contact with infected individuals. Once inside our bodies, they try to multiply and wreak havoc, leading to illnesses. Viruses, like the flu virus, are like sneaky invaders. They inject their genetic material into our cells, hijacking them to make copies of themselves. This process damages our cells and disrupts normal bodily functions, making us feel sick. Bacteria, on the other hand, are more like tiny factories. They multiply rapidly and release toxins that can damage our tissues and organs, causing a range of symptoms. Fortunately, our bodies have evolved a remarkable defense system to combat these microscopic foes, the immune system. This complex network of cells and proteins works tirelessly to protect us from infections. Think of your immune system as a well-coordinated army with different types of soldiers, each with a specific role. Some soldiers, like macrophages, are like frontline warriors, engulfing and destroying invading germs. Other soldiers, called T cells, are like skilled assassins, targeting and eliminating infected cells. And then there are B cells, the antibody factories. These cells produce specialized proteins called antibodies that latch onto specific germs, marking them for destruction. The first time our immune system encounters a new germ, it takes some time to recognize the threat and mount a full-scale defense. This is why we sometimes get sick. However, our immune system has an incredible memory. Once our immune system has encountered a germ and learned how to defeat it, it remembers the invader and can respond much faster and more effectively the next time around. This is where vaccines come in. Vaccines work by introducing a weakened or inactive version of a germ, or even just a part of it, to our immune system. This mock invasion triggers an immune response without causing the actual disease. Think of it like giving your immune system a wanted poster with a picture of the germ on it. This way, when the real germ shows up, our immune system is ready to recognize and neutralize it before it can cause any harm. The weakened or inactive germs in vaccines can't replicate and make us sick. Instead, they act like harmless imposters, triggering our immune system to produce antibodies specific to that particular germ. Section 5. Different vaccines, same goal. A look at vaccine types. Just like there are different types of germs, there are different types of vaccines, each designed to target a specific pathogen in the most effective way possible. Live attenuated vaccines like the measles, mumps, and rubella (MMR) vaccine contain a weakened version of the live virus. These vaccines are highly effective but may not be suitable for people with weakened immune systems. Inactivated vaccines, such as the flu shot, use killed versions of the virus. These vaccines are generally safe for most people but may require booster shots to maintain immunity. Subunit vaccines, like the pertussis, whooping cough vaccine, contain only a part of the germ, such as a specific protein. These vaccines are generally well tolerated and effective. Section 6. Vaccines in action, preventing diseases and saving lives. Vaccines have been one of the most successful public health interventions in history, saving millions of lives and preventing countless cases of debilitating diseases. Before the development of vaccines, diseases like smallpox, polio, and measles were major killers, especially among children. Thanks to widespread vaccination, These diseases are now either eradicated or significantly controlled in many parts of the world. For example, smallpox, a highly contagious and deadly disease, was eradicated in 1980 thanks to a global vaccination effort. Polio, a crippling disease that can cause paralysis, is now on the verge of eradication, with only a few cases reported each year. Vaccines not only protect individuals, but also contribute to herd immunity, a phenomenon that occurs when a large percentage of a population is immune to a disease, making it difficult for the disease to spread. Section 7. A triumph of science, the eradication of smallpox. The eradication of smallpox stands as a testament to the power of vaccines and the importance of public health initiatives. Smallpox, a highly contagious and deadly disease, had plagued humanity for centuries, leaving behind a trail of death and disfigurement. In the late 18th century, English physician Edward Jenner made a groundbreaking observation. Milkmaids who contracted cowpox, a milder disease related to smallpox, seemed to be immune to smallpox. This led him to develop the first vaccine, using cowpox virus to protect against smallpox. Jenner's discovery revolutionized medicine and paved the way for the development of other life-saving vaccines. Over the next 2 centuries, smallpox vaccination campaigns were implemented worldwide, gradually reducing the incidence of the disease. In 1980, the World Health Organization declared smallpox eradicated, marking a historic victory for public health and a testament to the transformative power of vaccines. Section 8. Herd immunity, protecting the vulnerable. Vaccines not only protect individuals but also contribute to a phenomenon called herd immunity, which provides indirect protection to those who cannot be vaccinated for medical reasons. When a large percentage of a population is immune to a disease, it creates a protective barrier, making it difficult for the disease to spread. This is because there are fewer susceptible individuals to infect, breaking the chain of transmission. Herd immunity is especially important for protecting vulnerable populations, such as infants who are too young to be vaccinated, elderly individuals with weakened immune systems, and people with certain medical conditions that prevent them from receiving vaccines. By getting vaccinated, we not only protect ourselves, but also contribute to the collective well-being of our communities, ensuring that everyone, regardless of their vaccination status, has a lower risk of contracting preventable diseases. Section 9. Vaccine safety, separating fact from fiction. Vaccines undergo rigorous testing and safety protocols before they are made available to the public. Scientists and health organizations constantly monitor their safety and efficacy. Like any medication, vaccines can cause side effects, but most are mild and temporary, such as pain or redness at the injection site, low-grade fever, or fussiness in infants. Serious side effects are extremely rare. It's important to rely on credible sources of information about vaccines, such as healthcare providers, public health agencies, and reputable scientific organizations. Misinformation and myths about vaccines can spread easily, undermining public trust and jeopardizing public health. Section 10. The future of vaccines, advancements, and new frontiers. The field of vaccinology is constantly evolving, with scientists developing new and innovative ways to prevent and treat infectious diseases. Researchers are exploring new vaccine delivery methods, such as nasal sprays and patches, to improve convenience and accessibility. Scientists are also working on developing vaccines for diseases that have long eluded traditional vaccine approaches, such as HIV, malaria, and tuberculosis. These diseases pose unique challenges, but advances in immunology and vaccine technology offer hope for the future. The development of mRNA vaccines, like those used for COVID-19, represents a major breakthrough in vaccine technology. These vaccines use genetic material to instruct our cells to produce viral proteins, triggering an immune response without using any live virus. Section 11. Keep exploring the world of science. Subscribe for more. Vaccines are a testament to the power of science and human ingenuity. They have saved countless lives and continue to protect us from preventable diseases. By understanding how vaccines work and embracing scientific advancements, we can create a healthier future for all. Remember, science is all around us, waiting to be explored. If you enjoyed this journey into the world of vaccines, be sure to subscribe to our channel for more exciting science adventures. Until next time, stay curious.